Hello, everyone. I'm Frank, and welcome to Learn How to Sudoku, where we take very easy variant Sudoku puzzles and we break them down into detail so that you can learn how to Sudoku. And today's very easy puzzle is called Fog of Never 4 by J. Rosas. And here are the rules. Ordinary, never four, fog of war, crop key, little killer, and arrow rules. Okay, so that's pretty complex. Let's break it down. And then here's the explanation of the rules. Never four. Place the digits 0 to 9, never four, in each row, column, and 3 by 3 bold outline box. So instead of the digits 1 through 9, which is normal Sudoku rules, this is never 4, which is 0 through 9, but never 4. So 0 to 3, and then 5 through 9 in each row. So instead of the 4, you replace that with the 0 instead. So you just use 0 instead of the 4, and you should be golden. Fog of war. Fog covers the grid. Placing a correct digit clears a fog in surrounding cells. No guessing is required. So basically, once you get a cell correct, you will clear all the fog in the surrounding cells, including itself, right? So you could actually correctly deduce that a cell is a certain number, and if you do, it clears all the fog around it and in the cell itself too. No guessing is required because you can you should be able to logically figure out this puzzle completely, just using logic. And guessing just randomly just sort of defeats the purpose of fog of war puzzles. But to each their own. You can do what you want. Crop key. Each white dot separates two digits that differ by 1. So for example, if this were a 3, this would have to be a 2 or 4 to be have a difference of 1 between them, which is also known as their consecutive too. And that's how white crop key dots works. Each black dot separates two digits. One of them is double the other. Not all crop key are necessarily given. So basically, in crop key dots, you know that you have, sorry, for black crop key dots, if you had, oh, well, okay. The 3 was wrong. If this was 3, this would have to be a 2 because, again, this is a never 4 puzzle. Let's use a different example. If this were 6, this would be 5 or 7 because you have to be, be consecutive for two cells to be separated by a white crop key dot. Now for a black crop key dot, if this were a 3, this would have to be a 6 because you have to maintain a 1 to 2 ratio between cells which are separated by a black crop key dot. And that's how crop key dots work. Little killer. A number outside the grid is the sum of all the digits along the indicated diagonal. So therefore, all the digits along this diagonal must add up to 9. And that gives you a pretty decent clue about how that works. Arrows. Digits in arrow sum to the number in the attached arrow. So let's say we had an arrow looking like something like this or whatever. And this, imagine there was like a little arrow here in the center. Maybe like something like that without the other X parts here. Anyways, say this was an arrow. Then you would know that these two digits must sum up to what's in the circle, right? So a valid possibility here would be if this was an arrow, would be if this was 2 and this was 5, this would have to be a 7. It's hard to read them. I can't put them in big numbers because I don't want to accidentally guess a random number in this fog. But if this was 2 and 5 and that's 7, that works as an arrow. And that's how arrows work. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so the simplest way here is looking at the little killer, right? The little killer has 9 digits, which all must add up to 9. And the minimum amount you can have for 3 unique digits for this never 4 rule set is 0, 1, and 2, right? Those are the minimum digits you can have for 3 unique digits in a row or a column or a box. And we know these 3 are in the same box, these 3 are in the same box, and these 3 are in the same box. Well, what's the minimum value you can have there? It has to be 0, 1, and 2, which means this adds up to 3 at minimum, this adds up to 3 at minimum, and this adds up to 3 at minimum. Well, that adds up to 9. So the minimum amount, which means you can't change anything to get to this, is 9, which means we know specifically in these cells are 0, 1, and 2, because that's the minimum possible. So this is 0, 1, or 2. Now, 0 cannot be in a 1 to 2 relation. I can't speak. Cannot be in a 1 to 2 ratio with any other digit except for 0. And then that would break this never 4 rule set, because then the 0 would be seen twice in a column, which is not allowed. So this can never be 0. Can never be 0. If this is 1, this would have to be 0 or 2. But we know that in box 1, 0, 1, and 2 have to be in these 3 specific squares. Therefore, they cannot be in the rest of the squares. So 1 can never be here, because this could only be next consecutive with 0 and 2. And so therefore, this has to be 2, which makes this a 3, right? Because we know this has to be 0, 1. 2 is in a 1 to 2 ratio only with 1, because 4 is never in this puzzle. So this has to be 1. 2 is also consecutive only with 1 or 3. This can't be 3 because of ordinary never 4 rules. So therefore, this has to be 1 also. So this can no longer be 1. This is in a 1 to 2 ratio. And the only possibilities to have a 1 to 2 ratio now for the never 4 rule set is 1 and 2 and 3 and 6. Well, 1 eliminates the possibility for this being 1 or 2. Therefore, this must be 3 and 6, which means... hold up, I'm getting a phone call. Let me pause. Apologies, I got a phone call and it's a number I don't recognize, so I'm just not going to answer it. I'll leave it for voicemail if the person actually is legitimate. Let's continue on with this puzzle. So, again, this must be a 3-6 pair, because it has to have a ratio of 1 to 2, and 1 and 2 are already gone. 4 is also not possible, so you can't have 2, 4, or 4, 8. So this leaves only 3 and 6, and therefore this can't be 3, so this must be a 6, which makes this a 3. Okay. This arrow, so this is the arrow I was talking about. We at least have 3 digits along this arrow. This cannot be 0, 1, or 2, so this is at minimum 3. This could be 0 or 2. So this is at minimum. Well, but if this is 0, it's consecutive with another digit. Well, 0 can only be consecutive with 1 of the other ordinary of never 4 digits. But we already have a 1 in that column, which eliminates the 1 from being in that cell. So this cannot be 0. It cannot be 1 or 2. It cannot be 3. This is at minimum 4. This is at minimum. I guess it could. This one could be 0. So it could be 0, 4, and 3, which means this is at minimum 7, 8, or 9. So this could be 0 or 2. And that would be the maximum you could have here. This could be 4, 5, or it cannot be 6. And it can't be 7, because if it's 7, this would have to add up to at least 10. So this is 4, 5, which means it could be with 3, 4, 5, or 6 here. We're not sure which. This can be 3, 4, or 5, because it could add up with 0 and 4 to add up to 9, or 5 and 4. Yeah, 5, 4, and 0 to add up to 9, or 4, 5, and 0 to add up to 9. What else do we know? The rest of these... Oh, there's no 4. I keep forgetting there's no 4 possible. So this can't be 4. This has to be 5 then. So this has to be 5 because there's no 4 possible. It's consecutive only with 6 because 4 is not a possibility. So this is 6. This cannot be 5. It cannot be 4. It must be 3. So this is 3 then. 3, 5, and 0 add up to 8. 3, 5, and 2 would add up to 10. So that's not possible. So this must be 0 and this must be 8. So 0 can no longer be here. The rest of these cells are 2, 7, and 9. And this can't be 2. This can't be 0 anymore, therefore this is 1, which makes this a 0. Again, this is a 1 to 2 ratio, so it can only be 1 and 2 or 3 and 6, but 3 and 6 is eliminated because we have a 3 here. Also, we have a 6 here, so that eliminates 6 from being one of those two cells. Therefore, this is a 1-2 pair, which means this cannot be 2, which forces the 2 in box 4. And we call this box 4 because of convention, where we have convention of reading from top to bottom and left to right as normal Western notation we have. So this would be box 1, this is box 2, this is box 3, this is box 4, this is box 5, 6, 7, 8, and 9. So in box 4, where can the 2 be? Cannot be here anymore, can't be here. It must be here. So this is a 2. This can no longer be 2, and it can't be 1, so this must be a 0, which means this can't be 0. The rest of this is 5, 6, 7, 8, and 9. And this cannot be 5 or 6. This can't be 8. This can't be 6. Can this ever be 5? No, because this digit is at least 7. So this can never be 5. This can't be 7 either because it adds 2 digits. And this digit has to at least be a 2. So then this has to be 7 and 2 to add up to 9 because that's the only possibility of a digit that would work with that. So this has to be 7. This has to be a 2. And this has to be 9. So this cannot be 7 or 9. Therefore, this is an 8. This can't be 7. So therefore, this is a 9. That 9 means that can't be 9. So this is a 7. And these can't be 7 or 9. So that's 5 and 6. What's the last remaining digit in column 1? It must be a 9. So again, as I said, if you logic out the correct digit in a cell, it'll clear the surrounding cells, but also itself. And it does. So this is 9. This has to be 3 or 0. This is 0 or 3. This has to be 5, 7, or 8 for the remaining cells. This cannot be 8, because if this is 8, that would mean it would have to be add up with another digit to add up to 8 or 9. 8 wouldn't work because you would have an 8 already in that column. So again, like if this is 8 and this is 0, this can't be 1 either. So this has to be 5 through 9. This is 5, 6, 7, or 8. This is 5, 6, 7, 8, 9. This could be 5, 6, 7, 8, 9. And this could be 5, 6, 7, 8, 9. Well, this can't be 8 because of that 8. This can't be 6 or 9 because of that 6 and 9. This can't be 6. So however this arrow works, it can never be essentially 8 or 7, right? Because say it extends further here, right? This would have to be at minimum 11. So if it extended further here, it would break the puzzle. Because you have a digit that would be greater than 9, which is impossible. So this arrow essentially has to end, well, it has to end here, right? It can't be here, because if this were the circle and this were the arrow, they would have to be exactly the same. So that's not possible. So the only possibility that this works, actually, is if this is 5, this is 3, and this is 8. And this is the end of the arrow. So that's what it has to be. So this is 5, this is 3, and there's 8, as I showed. These can no longer be 8. This can't be 8. And these can't be 5. Now, 9 in normal Sudoku and in this variant of never 4 Sudoku can never be on the arrow part of an arrow. Unless it adds up with 0. But the problem is we know it would have to essentially go outside. So, like, take, for example, that this wasn't a 9. Say you tried to have a 9 here, and say the circle was here. Well, the problem is you could only have 9, 0, 9, and that would work, but the problem is that would break Sudoku rules. Oh, this is also 0. So this can't even be 0 now. This has to be at least 1 with something to add up to something else. And it could extend further. We don't know. This one, actually, we don't have any other information on. We just know 9 cannot be there. So this cannot be 9. This could be... this can't be 0. Oh, well, there you go. This can't be 0 because of this 0. Now we have a 1, 2, 1, 2 pair in row 8. Which means 1 and 2 has to be in one of these two cells. Otherwise, if you tried to have a 1 or 2 outside of it, that would mean these two cells would both have to be 2, which would break the ordinary never 4 rules. So this cannot be 1 or 2. That means it's at least 3. This can't be 1 either because of similar reasoning. So this is 3, 5, 6, 7, or 9. So if this continued as an arrow, it would have to be at minimum 3, 5, and 6, right? So say this was not a circle. If this was continued as an arrow, part of an arrow, this would have to be at minimum 3 plus 5 plus 6, which is 14, which is obviously not a digit. So this has to be the circle. It has to be with 3, and it has to be 3 and 6. Because you have to add up to something greater than 8, because you cannot have 8 exactly, because this cell eliminates that as possibility for being 8. The only possibility now then means that this has to be a 9. So this is 9, as we showed. This is 3, and this is 6. So this can no longer be 9. This can't be 6 because of this 6. Now we have a 5, 7, 5, 7 pair in column 4, which means 5 and 7 cannot be in the rest of the column. Therefore, this has to be a 9. The rest of the remaining digits here must be 5, 7, or 8, because that's all that's left. These digits cannot be 0, 1, 2, 3, 5, so it could be 6, 7. Again, it cannot be 9, because if it's 9 plus 1, and it would have to be plus 1, because otherwise this would be the same digit, 9 plus 1 adds up to 10, which is not a digit. So this can never be 9. It could be 6 or 7 here. And this is 1 or 2, or 6, 7, or 9. And we don't know anything more about this. let's see. What's the rest of box 8? It has to be 0, 1, 2, 5, 7. And this is also 0, 1, 2, 5, 7. Interesting. Well, this can't be 5, actually. So, interesting. This has to be... We don't know where this arrow goes, though. What's the remaining cells here? Well, the remaining cells... Okay, this can't be 9. Where is the 9 in box 5? It can only be here. So this is a 9. It does go up. So this could be 7 or 8. It could be 7 if this is 1, 6. Or it could be 8 if this is 1, 7 or 2, 6. So this can only be 7 or 8 here. This has to be 5, 6, 7, or 8. We're not sure which, though. Let's see. The remaining digits here have to be 0, 3, 5, 6, 7, 8. Obviously, this can't be 3, and these can't be 3, and these can't be 0 or 7. These cannot be 8. What do we have? This can't be 7. This digit has to be at least 3. And it cannot be 5. If it's 5, well, first of all, obviously it can't be an arrow in a circle by itself, because then these would be the same digit, and we're prevented by never 4 rules to not have the same digit in the same row. So this has to be part of an arrow. Well, the only ones it could be now are 3, 5, 6, or 8. The problem with 5, 6, and 8 is if you have a 5, these two digits add up to greater than 9, which is obviously not a digit. Therefore, this has to be a 3. So this is a 3. This is either with 5 or 6. If it's with 6, that would add up to 9, but we already have a 9 in that row, so this cannot be 6. This must be 5, which makes this an 8. That leaves this as a 6 remaining, so this can never be 6. This can't be 5, so therefore this is 7, which makes that 8. This can't be 7, so this has to be 6, which means it only adds up to 8 with 2. So this is 2, this is 1. These cannot be 2 here. This can't be 2, this can't be 2, this can't be 5. These can't be 5, and these can't be 8. These can no longer be 6, and these can't be 1. This can't be 7, so this is 5, which means this can't be 5. These 3 digits must be 0, 2, and 5. Okay. Yeah. Okay. These 2 digits have to have, one of them has to be a 0. Because if we don't have a 0 here, what can it be, right? It would have to be at minimum 5 and 6 if it doesn't have a 0, which adds up to 11, which is not a digit. So 0 definitely has to be here. This also must be an arrow because it cannot be a circle. Because if it were a circle, we know 0 and adds up with another digit would only add up to that digit again, which is not allowed by the never 4 rules. So this has to be a it has to be a non-circle. So 0 we know has to be one of these 2 cells, right? Because if it's not 0, it's at minimum 5 and 6, which adds up to 11. So this is 0 with 5, 6. It could be 7 or 8. But this can't be 0 anymore, so this must be at least 2. So this cannot be 8. It could be 7. So this is 0 with 5, 6, or 7. Therefore, you cannot have a 0 anywhere else in the row because we know this has to be 0. And this is at least 2, could be 3. Cannot be 5 because then that would add up to at minimum 11. So this is 2 or 3 here. We have now a 0, 5, 6, 7 quadruple in row 3, which means 4 cells must contain the digits 0, 5, 6, and 7, which means 0, 5, 6, and 7 cannot be in any of the other cells. Therefore, this can't be 0, 5, 6, or 7, which means this has to be an 8. So this is 8. What's left here? This must be a 9, so this has to be 9. This cannot be 9. This can't be 8, so this must be a 5. The 3 or 6 must be in a 1 to 2 ratio with another digit, and therefore it must be also a 3 or 6. So this is 3 or 6. This can't be 3, though, because of that 3. So that makes this a 6, which makes this a 3. This can no longer be 3. This can no longer be 5. The remaining digits here are 1 and 8. Well, we know the circle has to go here. So this cannot be 8. And this can't be 8 anyway. So this is 1, which forces this to be 8. Which is 0, 5, 3 or 0, 6, 2. So this can never be 7. We have a 0, 5, 6 triplet in row 3 now, which eliminates 0, 5, and 6 from the rest of the row. So this can't be 6, which makes this a 7. That 7 means this can't be 7, so this is 0. This is a 6, this is a 5, this is a 6. This cannot be 6, so this has to be 0, 5, and 3 to add up to 8. This can't be 1 anymore, so this must be a 2, which makes this a 1, which makes that a 2. This can't be 2. Where is the 2? Okay, this can't be 2 either. Where is the 2 in box 3? It can only be here. So this is 2. This has to be 7. So this can no longer be 2. Where is the 2 in box 6? It has to be this cell. So this is a 2. Where is the 2 in box 8? It has to be here. This can't be 2. And this can't be 2. We have a 0, 1, 7 triplet in row 7, which eliminates 0, 1, and 7 from the rest of the cells in that row. Therefore, this can't be 7. This has to be an 8, which makes this a 7. Therefore, neither of these can be 7. This can't be 1. This can't be 7. Therefore, this must be a 9. So this is 9, which means this can't be 9. What's in the rest of row 8? Cannot be 0, 5 because of the pair there. It has to be 3 and 6. And this can't be 6. Therefore, that makes this a 3, which makes that a 6. The remaining cells have to be 7 and 9 because of what's left over. This cannot be 9. Therefore, this is a 7, which makes that a 9. This can't be 7, so this is 1. This is 7, which means this can't be 1, so this is 0, which makes that a 1. This can't be 8, so therefore it's a 5, which makes that 8. This can't be 5, so this is 0, which makes that 5, which makes that 0, which makes that 5. This can't be 1 or 7, so this is 0, which makes that 7, and therefore we have a 1. And those were all by, well, not normal Sudoku, but never 4 rule set. And I hope that gave you a good taste of variant Sudokus where you don't have normal Sudoku rules and you have different digits. I think this did a very good job of highlighting some of the differences you can have, right? Like the 4. Like this could not be 4, therefore, because of various rules. And I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.